Welcome to Data Do Library. In this video, we're going to talk about combinations of functions and composition of functions. There are four types of arithmetic combinations. There are sum, difference, product, and quotient. I will demonstrate each one of them with an example. Let's say that f of x is equal to 2x plus 3, and some other function g of x is equal to x squared minus x plus 1. Our first arithmetic combination is sum, which means that we can add two functions together, f and g of x. Another way it can be written is f of x plus g of x. All it means is that we're going to take function f, which is this one, and a function g, which is this one, and add them together and then combine like terms. Which means we're going to take f of x, which is 2x plus 3. We're going to add function g of x, which is x squared minus x plus 1. Now we need to just combine like terms and we will be all done. So let's identify like terms. X squared does not have a partner. It is all by itself, just x squared. 2x and x are like terms. They have x to the same power, which means they get combined together. So therefore 2x minus x is just 1x. And lastly, 3 plus 1 is equal to 4. That is the sum of these two functions. The next type of combination is the difference. Very similar to the sum, f minus g, two functions can be combined using subtraction. And it means the same thing as taking f of x minus g of x. The big difference here is that negative, and being careful with that negative being distributed through the second function. It is by far the most common mistake. So we take the first function, which is again f of x, in our case was 2x plus 3, minus the whole entire function g of x, which is why I'm going to put this in parentheses, because as you know, that negative needs to be distributed through the parentheses in order to simplify. And very often we only distribute that negative through the first term and forget about the rest. But we're subtracting the whole entire function g of x, which is why we're going to distribute. Therefore, we have 2x plus 3 minus x squared plus x minus 1. And just like before, we're going to combine like terms. In this case, again, negative x squared is all by itself. Negative x squared. We have 2x gets put together with x. That is positive 3x. And lastly, we have 3 and 1, or negative 1, and that gets put together as positive 2, 3 minus 1. And that is what you would get for a difference. The third kind is product. Product means multiply. Therefore, I'm going to have two functions multiplied by each other, f and g times of x, which means the same thing as taking function f of x and multiplying it by g of x. So in our case, we have 2x plus 3 times x squared minus x plus 1. So to multiply, we have to take each term and multiply by each term of the second parenthesis, which means 2x gets multiplied by x squared. When we multiply, exponents get added. Therefore, we have 2x cubed. We're going to take the same 2x and multiply it by the next term in the second parenthesis, which would give us negative 2x squared. and do the same thing one more time, which is 2x. Now we move on to the second term, which is a 3. We're going to again multiply it by each term of the second parenthesis. 3 times x squared is just 3x squared. 3 times negative x, negative 3x. And 3 times 1 is positive 3. Here, just like in the previous example, we are now going to combine like terms. 2x cubed can be combined with nothing. There is nothing else that 2x cubed can go with. So 2x cubed will be there by itself. We have negative 2x squared and positive 3x squared, which is going to be positive x squared. We then have positive 2x, which I'll use 3 lines for, and negative 3x, that will give me negative x. And lastly, I have this lonesome 3 by itself, and that will give me plus 3. That will be the answer to the product. Lastly, we have the quotient. In this case, I'm going to do a little backwards and do g divided by f of x, and which means g of x divided by f of x. But we also have to stipulate here that f of x cannot equal to 0, because if it does equal to 0, obviously the denominator would be 0 and we would have no solution. So that is one of the stipulations we have to have here. And it's a good practice to name the values that x cannot be the denominator, which is obviously easier to do for f of x than g of x, which is why I switched it around. So we're going to take g of x, which again is this function here. We have x squared minus x plus 1, and divide it by 2x plus 3. And that is pretty much it, except we want to name what values x cannot equal to. So in order to find out when is the denominator equal to 0, we have to set the denominator equal to 0 and solve for x. So I'm going to subtract 3. 2x is equal to negative 3 divided by 2. X is equal to negative 3 halves, which means that this is my quotient, but x cannot equal to negative 3 halves, because if it does, the denominator would be 0, and again, we have no solution. At this point, I encourage you to pause this video and take a look at this example. See if you can find some difference, product, and quotient of these two functions, f and g of x. I hope you pause this video and try to work this out. So in the first one, we have to add functions f and g together. So f of x, again, is this. I'm going to write it as 2x minus 1 plus g of x, which is this function, x squared minus 4. And I simply going to combine like terms to get x squared, which is all by itself, 2x is also by itself, and negative 1 and negative 4 give me negative 5. In the next example, it's the same thing, just with a subtraction. So we have 2x minus 1 minus, and this is where that parenthesis comes in, because you want to remember to distribute that negative. X squared minus 4, which is going to equal to. Now in here, we might want to do that extra step and distribute this negative. So we have 2x minus 1 minus x squared plus 4. Remember, the signs change. Two negatives make a positive, which is equal to negative x squared, because that is the highest term without any friends with it. Then we have positive 2x. And then lastly, we have negative 1 and positive 4, which would make positive 3. The next one, we're going to multiply f times g. So again, I have my f of x, which is 2x minus 1. I'm going to put that in parentheses. And then I have my g of x, which in this case is x squared minus 4. So we have two functions here with two terms. We're going to use FOIL method. And FOIL is first, so you're going to multiply the two first terms, which would give me 2x cubed, outer, which is negative 8x, inner, which is negative x squared, and last, which is positive 4. So FOIL is first, outer, inner, last. In this case, notice there's no common terms to combine. There's nothing we can combine. So it's a good practice just to rewrite it in decreasing order of powers. We have 2x cubed minus x squared minus 8x plus 4, which is our answer. Lastly, we have our division of f divided by g. And again, I have my f of x, which is 2x minus 1, divided by g of x, which is x squared minus 4. And at this point, you're pretty much done, except that you want to say what values can x not be, because it would make the denominator equal to 0. So somewhere on the side, you want to set the denominator equal to 0 and solve for x. I'm going to add 4, which gives me x squared is equal to 4. Take a square root, and if you remember, taking a square root of a square always produces plus or minus, and square root of 4 is 2. So in this case, there are two answers, or two numbers that x cannot be, which are x cannot equal to plus or minus 2, because either plus 2 or negative 2 would produce a 0 here in the denominator. Next topic for today is combination of functions. Combination of functions happens when one function replaces the domain of the other function. So the way you will see it is very often f of g of x. Denote it something like this. Sometimes you'll have f of g of x, something like that. And again, it's read as f of g of x. Other ways you can see it f of, or g of f of x, which again means the same thing as g, like an open circle like that, so you don't get it confused with multiplication, and g of f of x. Sometimes you may even see two functions into each other, f of x, something like that. So let's see what that looks like with an example. Let's say I have two functions again, one f of x, which we'll just call it x squared. And let's say another function g of x, which is x plus 1. Let's say we want to find f of g of x. What this means is, again, function f, the domain of function f, is going to be replaced with the whole function g of x. So what you want to do is work from inside out. On the inside of this function, we have g of x. In other words, instead of writing g of x, I can rewrite this as f of x plus 1. Now, I'm going to go into the function f and plug that in everywhere I see an x. So instead of this variable x, I'm going to plug in x plus 1, my function x plus 1, which would equal to x plus 1, that's what I'm writing instead of this x, and square it. Another very common mistake I have seen in my years of teaching is everyone saying that this is going to equal to x squared plus 1 squared, which is just 1. That is incorrect. We have to remember that x plus 1 squared is equal to x plus 1 times x plus 1, in which we have to FOIL x squared plus x plus 1, combine like terms, we get x squared plus 2x plus 1, which would be my final answer here. So remember not to make this very, very, very common mistake when solving these equations. We could have also done this the other way around. Let's say the question said g of f of x. That would mean g of, instead of f of x, I'm going to write what my f of x is equal to, which is x squared. And now I'm going to take my x squared and plug it into g, which means I'm going to replace an x variable with x squared everywhere in g. So in g, there's only one of those. I'm going to replace that x with x squared, but then I still have that plus 1, so I have to make sure to add that in. And there we go. Another type of question you will see here is evaluating at an actual point. So let's say I wanted to evaluate f of g of 0. One way you can do it is find f of g of x, which we did here, and then plug in a 0. That would definitely work, and I'm sure you can see that if I plug in 0 for x, I have 0 squared plus 2, 0, 2 times 0, which is 0 again, plus 1, which would be 1. But also another way to do it is to, again, work from inside out. Take 0, plug it into g. So I'm going to go into my function g, and instead of x, I'm going to write 0. Into that x, I'm going to write 0. So 0 plus 1 is 1. So now this right here gets replaced with a 1. So it's f of 1. Now I'm going to go into f and plug in a 1. So I go into my function f, I'm going to plug in a 1 here, which is 1 squared, which indeed is 1. As we saw before, we got the same answer here. This again is the part I encourage you to pause your video and try to work out this example. We have two functions, f of x and g of x. You're asked to find f of g of x, g of f of x, and g of f of negative 1. All right, so welcome back. Let's take a look at these three examples. We have f of g of x. So again, instead of g of x, I'm going to write what my function g of x is equal to, which is 3 minus x squared. And now I'm going to go into f of x, and instead of x, I'm going to write 3 minus x squared. So I'm going into here and writing 3 minus x squared, and then I still have this plus 2 left over. So plus 2. In this case, we have two like terms we can combine, just 3 and 2. We have negative x squared plus 5. The second example, we're going to work it out the same way. We're going to work from inside out. We have g on the outside. On the inside, we have f of x. F of x is nothing more than x plus 2. And now I'm going to go into g and replace x with x plus 2. So instead of writing x squared, I'm going to write x plus 2 squared. But that 3 is still there, so I can't forget about that. I have 3 minus, and because it's negative, I'm going to be careful with negatives here and open a parenthesis. And I have another parenthesis, x plus 2 squared. So now, as in one of the previous examples, we have to FOIL, which means we have 3 minus, we're going to FOIL, and I'll do that here on the side, x plus 2 times x plus 2. We have x squared plus 2x plus another 2x plus 4. We have x squared plus 4x plus 4. So that's what I get from this multiplication. X squared plus 4x plus 4. And now this is why I had that extra parenthesis in there, because now I remember to distribute that negative through the parenthesis. If I didn't have that, I might have been more prone to forget that that negative applies to the whole entire function there. So we have 3 minus x squared minus 4x minus 4. And notice the only two terms we can combine here are 3 and negative 4, where I find an answer being negative x squared minus 4x minus 1. And for the final question, I could use g of f of x, which is this, and plug in a negative 1 and see what my answer equals. Or I could go back and work it through inside out. So working from the inside, I'm going to take negative 1. I'm going to plug it in everywhere I see an x in f of x. So I'm going to go into f of x, which is here. And instead of that x, I'm going to write negative 1, which means negative 1 plus 2, which is 1. So this whole thing now turns into a 1. And I have a g on the outside. Now I'm going to go into g and plug in a 1. So I'm going to go over to my function g, and instead of x, I'm going to write a 1, which means I have 3 minus 1 squared, which is 3 minus 1, which is 2. Thank you very much for watching this video. I hope you found this helpful. Make sure you like and subscribe for more videos, and I hope to see you next time. Take care.